Welcome to Code Club. I am joined today by some esteemed gophers. Welcome, Thiago.
Hey.
Welcome,
Hello.
welcome, Jan. Mostafa is with us. Nice to see you.
Thank you.
Richard is also here,
Everyone.
and Sherif is with us. How are you doing?
Hello.
Thom is also in. Nice to see you.
Good morning.
Let's get cracking. So, I thought it might be fun to talk about thumped this week. So, that's how it's pronounced, by the way, in case you're wondering. That's like most important thing to understand about the thumped library is how to pronounce its name. Anybody used this library before?
Yes.
I have a suspicion that we all did.
Yeah, of course you have. It's just about the one that you can just about guarantee everyone will have used. But have you ever looked into it? I mean, have you ever read the source code? Has anybody ever had a look inside under the hood? No, I thought not. Because why would you?
Yeah,
It's-
I had like a cursory look, John. This is Richard. So looking at it, so Printline uses standard out, and the what was the other one? Fprint uses IO reader.
Yeah. Yeah,
But,
absolutely. So,
Anything more than that would.
yeah, perhaps you got the sense that there was a bit of a rabbit hole there, which, you know, if you follow it, it's quite interesting. So I thought we might do that. So I know we've dedicated a previous Code Club to a one-line program, that was a very interesting line, though, I have to say. So today we've got a two-line program. Actually, it could have just been a one-line, but let's make it two to make it a little more interesting. So let's see if we can run it. Great, no surprises. So my question is, how does that work? It's always the same question, isn't it? So let's have a look. So we're calling thumped printf, and those of us who've used it will know it takes a string which is a format string, and then it takes some data. So you've got things like thumped println, which just doesn't take a format string, just takes some data to print. That's all right. But this is more interesting because you can kind of supply static text plus some of these placeholders. Like, we'll be familiar with some of these, like %s means here comes a string, %d means here comes a decimal number, and so forth. So you could think of it as being, it actually implements a little language, couldn't you? Like, it's not just the placeholders, but, you know, if you have, you got some formatting options. So like if you have numbers, you could say, you know, print this number 2 columns wide, right? Or 5 columns wide or something. And please zero pad the number if it's not that wide. Things like that. Or if it's a float, you know, you could say, give me print that float to a position of 1 decimal place. That kind of thing is always useful. So we'll see how that is implemented. So let's take a look. Let's dive through and see what Printf does. Well, wow, Printf is a lot shorter than I expected. So I was expecting this to be a whole thing, but actually it isn't. So let's see if we can work out what's going on here. So Thiago, perhaps I can call on you, and perhaps you'll just read us through it, you know, in traditional Code Club fashion, and we'll see what we can figure out, shall we?
Sure. So we are declaring a function called printf that receives format variable type string and variable called a, which is one or more interface,
Right.
and it's going to return a named variable n, and
Yeah, that's interesting, isn't it? You didn't know Printf returned anything. Or maybe you did, but it's unusual to actually do anything with it. Any idea what n is?
the number of the bytes written to uh, to the IO writer.
Yeah, I think that's right. That's the same semantics as read and write, isn't it? Is that write, as in IO writer, it returns the number of things that successfully wrote plus any error that it may or may not have encountered. So yeah, okay. So how's that implemented?
So basically, call another function fprintf that receives an IO writer because it's the standard output, a format, and the number of the interfaces that we passed.
Right. So those are just any number of any kind of value, right?
Yeah.
So yeah, we can kind of see from this that we thought printf was the thing, but printf is not really the thing. fprintf is the thing. This is just a special case of fprintf. fprintf says print something to somewhere, and printf is just a convenience wrapper that always prints to os.standardout. That is usually what we want to do, isn't it? So makes sense. But you could get by your whole life with just fprintf and never worry that this exists. So shall we dive one level deeper? We'll see how that works. Okay. Can you walk us through this?
So we are declaring the function fprintf that receives a variable w, which is an IO writer format, which is a string, and a, which is one or more empty interfaces, and also returns the same thing, the n and error. So it creates a new printer and assign the return value to p.
Yeah, we don't know what a printer is yet, but
right.
We may figure it out. We can guess, can't we?
Yeah. So we call a method in P called to printf, and we pass the format and the interfaces.
Right.
And finally, we call we call the function write in the IO writer.
Yeah, I think the black helicopters are coming for you, by the way.
Yeah, sorry. So we call the function write in the IO writer and pass a buffer which is inside of the P, and we call another method called P, another method called free inside of P, and we return.
Okay, so what do we think this is about? Any clues? I mean, one thing that's interesting is that we have some object here, don't we? Like whatever new printer returns it's something that has methods, so it's some kind of struct. In fact, if you think about it, printing stuff, you're kind of like a little state machine, aren't you? In that you have some things to print, and at any given time you will have printed some of them or not, and have some things remaining to print or not. So you have state. So we do what we always do in Go, which is create a struct to stuff that state into, and then we can write methods on it. So clearly, a printer is the thing that does the printing. Let's see what that returns. Returns a pointer to a PP. Okay, so we'll find out what a PP is. It has a doPrintf method. So even this isn't really the thing. This is really the thing. fprintf is just a wrapper around this. PP is an internal type to this library, so it's not something users can fiddle with. It's just internal, but we create a PP, we ask it to print the data that we got, and evidently that causes something to happen in p.buff, because then we call write on the IO writer that we were given, which you remember in our original program was os.standardout. So we're calling write on that, giving it this buffer, which so we know it must be a slice of byte because that's the semantics of write. We know what this n and is about. What about p3? Any ideas?
It seems kind of like a close operation, possibly something that says, hey, I had some kind of a hold on some kind of resources. You know, now I'm done. Free them up.
Yeah.
Perhaps.
This is interesting. So free saves used
some file maybe.
Says saves used pp structs in pp3. So we'll see what this is about later on, and it's actually quite cool. But we can think of it as being like, yeah, this p is a little object which contains the printing state, and clearly if we're doing a lot of printing, we'll be creating a lot of these and then throwing them away. So to avoid lots of garbage collection cycles and memory churn, we probably want some way to reuse these things if we can, like pooling database connections or anything else that takes resources. What about this return statement? Any comments about that? Let's do a little code review.
Certainly violates one of the commandments, doesn't it?
Yeah, which I can't remember which number of the BIT commandments it is, but it's high up there. Thou shalt not write naked returns, right?
Yeah.
Anybody care to explain what that means for the benefit of those who don't know? There will be some.
A naked return is not specifying a return variable or a value. So it isn't the default nil if nothing's specified.
Right, so we're saying the function signature says we return an int and an error value, and we didn't explicitly return something, so what is it that gets returned? What actual values?
I think, yeah, sorry?
No, go ahead.
That's actually one thing that was confusing for me coming from Python, where when you use basically this kind of naked return, you get none or nil. But here, what is actually returned, it was the function signature state. So in this case, it's n being of type int and r being of type error.
Yeah, so we're saying that by giving these return values names in the signature, they actually kind of act like local variables, don't they? So when we assign to them here, that's what we're really assigning to. We're assigning to these return parameters. And then when you say return and nothing else, you're just saying return n and r, aren't you? Yeah, that's absolutely right.
I do have a comment about it. In the Go tour, I know it's not for experts, but they say it's okay to use naked returns with short functions. And like I don't see a problem to read that because my return is like 4 lines after my function signature. Is that something really we shouldn't do at all?
Well, clearly this is something that Go allows you to do syntactically. The compiler lets you do it, and we don't think of the Go compiler as being very kind of laissez-faire and easygoing, do we? Like, it's really hard to get anything past the compiler, so the fact that it's okay with this is interesting. Well, why might that be a bad thing? I mean, we obviously can write n and r, or anything else we want there. So what might not be so great about not saying anything? You know, why would I have a commandment not to write naked returns, for example? Maybe I'm just an idiot, but let's see if there are any alternative theories. I'm not ruling that out.
I mean, clarity. Other than clarity, you know, when you, depending on the length of your function, if you just say return at the end of it, you have to then go back through, reread the function, and go, oh, okay, well, they did name your variables at the, in your function signature.
Yeah, I completely agree with that. But my point is, like, if you have just 2 or 3 lines, and even the Go tool, they say that's okay, like, to use. So my main doubt is, and the standard library is using it, so, like, why this rule exists, you know?
Yeah, I do hear
I
that
think
kind of thing.
I think maybe I'm sorry.
Go ahead.
Maybe it's just enforcing good practice by.
So the standard library is not following good practices.
Well, I think
That's
yeah. I think, but you had mentioned in a earlier code club, John, that the standard library code may not be a model to follow because it was written so early on and like it didn't get cleaned up after.
Yeah, that's a fair point. Well, I mean, clarity is absolutely what this is about. I mean, the fact is, it was not 100% clear to all of us exactly what was being returned here. So that's it. As far as I'm concerned, that's enough to say it's not worth doing this. Because what did we gain from omitting n and er? Well, nothing. So why do it? I mean, I don't understand why. I can understand some of the arguments saying it's okay to do this, but I don't understand what the motivation is in the first place. And I really can't think of it, except less keystrokes. I mean, if you're worried about wearing out your keyboard, I mean, an Amazon Basics keyboard isn't that expensive, so I don't know. But
I think for me, yeah, I understand what you're saying, but you have very similar function signatures, so maybe just want to avoid, yeah,
yeah, I
just
mean,
copying. Yeah,
I think what you're saying, Thiago, is you can get away with this in cases where it really doesn't reduce the clarity that much. It's not like you'd have to do that much extra work to just trace through. You'd have to go back to the function signature. You'd have to say, what are the names of the variables that I need to look for? And then you just read through the whole function saying, are these variables ever assigned to? And in fact, what is the last assignment to these variables? And then, okay, now I know what values are being returned. But you could have saved all of that by just simply writing return n and error. And, I'm putting this out there right now. I'm calling out the Go team. Like, this is not on,
So what about, and I'm sure that the answer is that it's trivial, but, doing this, essentially naming your variables in your function signature is a form of syntactic sugar, right? The compiler is going to take that and it's going to create variables from that, either by adding lines when it creates when it cleans up your code or reads through your code that say var n of type int.
Yeah.
And that again, I'm sure it's trivial and maybe not even measurable, but presumably it could add some kind of overhead to compiling your code.
Yeah. Yeah, I mean, I'm always much more concerned about the cognitive overhead for people reading the code, because it's often me, I only have a limited number of brain cycles available. I don't want to waste any of them. And it's a bit like microaggressions, isn't it? Every tiny thing you do that just makes the reader stop and think, wait, what's happening there? If you add up 10 or 20 of those over a function, it actually starts to have a measurable impact on how long it takes you to read and understand it and how well you understand it. So my advice is always make a little extra effort as the author so that the reader has to make commensurately less effort, which I think is a nice attitude, isn't it?
I think it's worth pointing out, John, that I think, and correct me if I'm misunderstanding what you said to me, is that when you're saying don't avoid naked returns, you're not saying avoid naming your return variables,
Yeah.
or what returns from your function.
That's a great
when
point.
they're just you can certainly do both, but there's times when it's important to be clear in your function signature as well. You might want to name something as, instead of n, like bytes written, or something.
That
so
would have been
it's
better,
easy
yeah.
yeah.
So we're really putting the standard library to pieces, and that's a little unfair. I mean, the thing is, as you rightly say, most of it was written a long time ago and now cannot be changed for compatibility reasons. And the other thing is, the standard library is a very unusual kind of library. It's not just any old Go package. First of all, it's one that every Go programmer will have. So, you know, standard library code needs to be much more general than any old library I might write. It needs to handle every possible situation, every machine, every architecture, every operating system, every Go version, every imaginable type of program, every kind of problem you could run into. It also has to be extremely high performance, precisely because, you know, if you allocate 1 byte of memory that you don't need to, multiply that by all the Go programs running right now around the world, that's a lot of wastage. So, you know, it's in places it's really heavily optimized, which means, you know, if you've optimized code yourself, you'll know what you end up with is a bunch of complicated and ugly special cases and edge cases and shortcuts, and it's generally not much fun to read. So you definitely shouldn't look into the standard library and go, right, whatever they do, I must copy it so my code looks exactly like that. You know, remember these special constraints that are on this library. And the other thing is, you know, when Go was first invented, no one had a lot of experience writing Go, so they really didn't know how to do it that well. So as most of us know, you know, a lot of times you learn what not to do by just doing it wrong and then going, oh, I'm not going to do that again. That was a nightmare. But now imagine, you know, that you already released your code to everybody in the world and it can never be changed, so you're stuck with it. So that's the situation. So that's a caveat, if you like. It's extremely interesting and instructive to read in the standard library, and I recommend it. Taking it as a model or advancing it as an argument for why you do something and say, but the standard library does it. Fine. Well, when you submit a package to the standard library, let me know. But, you know, and it's perfectly up to you, of course. You know, if you find it clearer, for example, to write naked returns, please do, but I've found by experience that it's helpful for people learning. You know, you could say to people, oh, well, in this situation do that, but in this other situation sometimes it's okay to do that. Now they're really confused because they've got two possibilities, and they have to, every time the situation comes up, they have to choose what to do. They just don't need that kind of roadblock. So the best thing to do is give people a simple rule that they can always follow, and they'll always be safe. You know, it will never be wrong to avoid writing naked returns. So that's one thing. But the point was absolutely right, that sometimes you like to name your return values. Maybe it adds documentation. Not in this case, though a name like bytes written would have been much better. But the fact is, N is conventional, because everybody knows that as part of the reader-writer interface. So this is actually correct. And the fact that you name them does not then mandate that you have to write a naked return. That's the important point.
John?
Yeah.
Since you already touched the topic, I would like to hear your take on this, because as I said, coming from Python, in Python you are often you are advised to write very explicit names for variables, like bytes written, like you said. But in style guides for Go, you are often advised to use variable names like n or like r, those very short ones.
Yeah.
So I often struggle to decide where's the limit there.
Yeah, I think that's a great question, and you know, naming things is the number one hard problem in computer science, as we all know. I frame it this way: like if you said your variable names should always be just one character, that's clearly ridiculous, isn't it? Like nobody would seriously advance that argument. If I said your variable names should never be less than 12 characters, that would also be completely silly, wouldn't it? Like if you have a for loop, obviously the index variable is going to be called I. There's no need to call it index variable or something. So what are we really saying then? What we're really saying is it depends on the situation. We don't want to write a name that's longer than necessary. That just clutters up the code, and it actually makes it harder to read, because reading n characters takes n times longer than reading one character, right? So we don't want to waste characters, but also we don't want to cut names too short so that we're puzzling over them trying to work out what they are. I incline to a similar idea to Einstein when he said that everything should be as simple as possible, but no simpler, right? Variable names should be as short as possible, but no shorter. And as short as possible means as short as they can be while still being clear. So that's really the rule of thumb, isn't it? As you say, if my choice of name is clear to the reader in the context that it's in, then we're all good. Like, N is clear here because we're familiar with the IO reader writer interface. For example, P is fine here. Like, we can see it's assigned by something called new printer. The type is actually called PP, so we can think of it as a printer. We could have used printer instead of P, but why? We only use it 4 times within 4 lines, and then that's it. So P is all right here.
Yeah, that's a really good guideline.
And I think that applies in any language, doesn't it? I mean, I think there are always great practices to be found, great ideas and great practices to be found in any language community. Even if it's not a language you know or you use, there's almost certainly some good idea, right, that you can learn and take away and apply yourself. So I think things like this count under that heading. Like, there might be people who dip into Go a little bit and they say, oh, I like this idea that names should be as short as possible but no shorter. I'll use that. It's definitely not Go specific. So, fine. So I don't wish to cut short this fascinating discussion because I like digressions, but
Sorry for sidetracking you.
Not at all. It's exactly the kind of sidetracking that I want to do. I mean, the whole point of these sessions is to generate interesting conversations, isn't it? Interesting Q&A, and we are, so we're doing a brilliant job. Keep it up. I just want to take a moment to tell you about a series of ebooks I'm writing for Go beginners called For the Love of Go. In Book 1, Fundamentals, I show you how to write tests in Go and how to build programs test first. In Book 2, Data, I tell you all about variables and values in Go and data types like slices and structs. If you're new to programming or just new to Go, I'll show you everything you need to know to start building fun and useful projects. Go to bitfieldconsulting.com/books and enter Code Club at the checkout to get 25% off now. So let's try and dive a little bit deeper. So let's try and find out what this PP is. So let's take a look. So let's see here. So we've got something called PP3 and it's a sync.Pool. Anybody familiar with sync.Pool? I'd say don't feel too bad. It's a reasonably obscure construct. But
is there a way of synchronizing multiple coroutines or to limit the number of coroutines you are going to run?
Well, it's in the sync library, which is an important clue, isn't it? So the sync library contains things like sync.mutex and weight groups and good stuff like that. So a sync pool is actually the thing that enables us to do what we were saying earlier about reusing stuff. So suppose you had some expensive struct, takes a lot of memory, and you're allocating a lot of them, and you don't want, every time you allocate memory and then you release it, you cause a garbage collector cycle, and then that could hurt your performance. So if that's happening a lot, you would like to say, actually, let's just make 100 of these and I'll just always reuse that pool of 100 or something, or whatever it is. So what we're really doing here is we're saying, do I have an existing PP that I can just reuse from a previous print statement? Fine, I'll reuse that. no reason to reallocate all that memory if I don't need to. Or if there isn't one, maybe I'm the first print statement, then just create one. So sync.Pool has this API where you're like, give me a function that creates a new whatever it is, and I will then allow you to call get on this pool. And if there's something in the pool, you can have it. If there isn't, I'll call your provided new function to create one. And the only slight wrinkle about that is because Go doesn't yet have generics, this can't actually return your type because it doesn't know what your type is. It returns empty interface, and it's then up to you to say, I'm going to type assert it to the specific thing that I know it is.
Is it normal in this kind of a case to not check that the type you got was what you expected? And I know that this is private to the package, so they have, someone isn't going to make a change outside of, the control of the package. But
yeah,
that seems odd to me that there's no checking at all here.
Yeah, that's a great question. So just elaborate slightly on what you're suggesting might happen otherwise.
Well, sure. I mean, so if you let's say you called get on pp-free and somehow you didn't get, I don't know, maybe somebody had to reset the value of pp-free to a different type of, different sync.Pool that returned a different type.
Yeah. Actually, let's wind it back a step further and just say, let's pretend we don't know what a type assertion is. So what is that? So what we're saying is some interface type, in this case, the empty interface, which can be literally anything. We are saying, actually, I want to assert that this is in fact some concrete type, like a pointer to pp, because I want to use it as one. If I have a pp, I can call methods on it like do printf. If I have an empty interface, I can't do that, because empty interface precisely says nothing about what methods may or may not be available. So the compiler won't let you call one. It doesn't have a YOLO mode where you're like, I hope it's going to be this type, so I hope this method call will work. Some languages do work like that. So we use this construct called a type assertion, which is just to say, you say the value and then you say dot, and then in parentheses the type name that you would like it to be. And if you think of an interface as a kind of a box in which some concrete value is hiding, but you don't know what, this is opening the box and assuming that there's a pp inside. If it is, then fine, p will be a pp. If it's not, this will panic, in fact. So what you were saying, Thom, was that it's common to see when you do a type assertion. I would call this a hard type assertion in that it panics if the assertion fails. You can do a soft type assertion which says you receive a second value called conventionally OK. That's just like the OK that you get from a map lookup or a channel receive, for example, and it tells you, yeah, it was OK. It was that type. If it wasn't, if it was a string or an int or something, OK would be false and we wouldn't panic. So now you can check OK and say, actually, did that succeed? If not, I can choose what to do. Hopefully not panic. So why would you not do that, I think was the question, wasn't it? And
yeah, I mean, I could think of some ideas of why I wouldn't want to do that here. Maybe it's because, again, like this API isn't exposed for somebody else to use, yeah. Right? It's private, meaning I, as the owner of the Thom's package, have control,
yeah.
And also, maybe it's acceptable to, in this type of a library to panic.
It's never acceptable to panic. But I'm not in charge of the standard library as yet. I keep writing to them about it, but yeah, so I would prefer to do a soft type assertion here and check it, and I'm pretty happy to say that everybody else always should do that as well. Basically, there's no reason to do a hard type assertion unless you're worried about wearing out the OK keys on your keyboard, or you just simply know that it cannot fail. Like, there are cases where the way the code is written, it cannot be anything else, but you just can't prove that to the compiler. So, you know with cast iron certainty that the result of this is going to be an interface value containing a *pp, which we do. That's the API of sync.Pool, as you said. The only way things can get into sync.Pool is by calling your new function. So assuming your new function is correct and returns the right type, then we're all good. But the compiler doesn't know that, so we need to just say, by the way, it's going to be a *pp. And yeah, the question is what... Sorry, go ahead.
I was just about to comment that the usual framework for telephone provider does like that. They pass an empty interface, but we are sure of the type, but
yeah,
we need to do a assertion. It's
that's right.
To convert from the data to the type we want.
Yeah, that's right. So if you write a lot of Terraform providers, as you and I do, you use a lot of type assertions, don't you? Because basically everything in Terraform is empty interface, and then we assert it to the type that we hope it will be. So that definitely happens a lot. And so the question would be, if we were to receive the OK, what would we do with it? Well, we could say, if not OK, no point panicking, or we don't need OK, but you could return some error. And the thing about that is then you'd have to change your function signature return error, and then you'd have to handle that error in the place where you call new printer, wouldn't you? And then what would you do if the error was not nil? Well, that problem would percolate all the way back through the code, and it's a deep stack, as we're going to see. So I think, yeah, essentially what you said is right, Thom, is that in that they control both ends of this. So if this should ever panic, by gosh, that'll be a GitHub issue pretty quick, right? Nobody can print anything in Go all around the world. There'll be a lot of angry users. Hopefully that would be caught by some kind of smoke testing. You never know. But yeah, so I don't... so again, don't do what the standard library does. Don't do what Donny Don't doesn't do. So let's see what else is happening here. So we've got a PP from the pool. We don't exactly know what a PP is yet, but we'll find out. It's not panicking, so it has a Boolean field called panicking, and presumably this is like, imagine that something does panic. It could happen, and we're deep inside a printer trying to print stuff. That's actually going to result in some printing, isn't it? When your program panics, you see some text. Somebody has to print that, and it's probably thumped. So we need so imagine that, something goes wrong internally with the printer, and it has to panic, and then it tries to print out the panic message, and then it panics again, and then it tries to print out that panic message, and, there's no end to that. So we need a way to short-circuit that loop by saying, don't bother doing anything, I am already panicking, kind of thing. Don't get stuck in an infinite loop. Same thing with erroring. Wrap errors. We haven't got time to go into that now. Let's do a whole code club on error wrapping, shall we? Because that's kind of fun. And thumped init does something with p.buff. So we know p.buff is the thing that's going to end up being written to the writer. So that's helpful. So we've got a printer. That's fine. Now we're going to do a printf with it. So Jan, could you help us here? Perhaps you'd just read us through the beginning of this, and we'll see if we can work out what it's about. Because it looks interesting, doesn't it?
This declares a receiver function on a pointer to PP.
Yeah.
Called toPrintf. It takes in a string, and it takes in a slice of interfaces.
Yeah. So it was previously, so all the way back in our original program, that was these two things, wasn't it? It was the format string plus a list of 0 to n data values, and we receive those variadically here with the ... and we pass them on using the ... again to say, you know, when you have the ... here, that means 0 to n parameters which you will receive as a slice. So inside the function a will be a slice that you can loop over. But if you want to pass that slice on to some variadic function and unroll it into variadic parameters again, if you like, that's what the 3 dots does. So I think of that as the unroll operator. I think Todd McLeod refers to it as unfurling, which is a better name. I should have stolen that from him. So inside fprintf though, so a is a slice of our variadic arguments, but we're not unfurling it or unrolling it, we're just passing that slice, which is okay. So as you rightly said, Jan, this is now just a slice of empty interface, so fine. What do we do with it?
So we get the length of the string.
Yeah, we're going to need to process this format string in some way, aren't we? Like, one thing that would make sense would be start at the beginning of it and work your way through to the end, trying to print everything in there. So we'll need to know when we've got to the end, so we might guess that's what this is about. Carry on.
Set the, I guess, number of arguments to 0. We process one argument per non-trivial format. Well, I can't unpack that.
Yeah, so actually that might be the current argument number, mightn't it?
Yeah.
Is it saying one argument per non-trivial format? Well, ignore the non-trivial. You know, if the format is the placeholder, you're saying if there's a %s, there also needs to be some data value in a that matches that. And for all of the % placeholders, we need to find a corresponding value in the argument slice. I think that's what that's about.
After index is false. So what's that about?
Yeah, this is a very obscure feature of FUMT, which I don't think I can even remember it well enough to explain it. But let's ignore that for now and come back to it.
And we also set the field of p. We set the field reordered to false.
Right. Don't know what that means. Probably not important.
And
A big part of code reading is actually knowing what to skip over, isn't it? And not worry too much about. Because if you get hung up on every variable that you're not sure what it's about, you're almost bound to find out later, aren't you? So a lot of the time we just say, if it's not obvious, I'll just move on. So you're doing exactly right. Keep it up.
Yeah, and then we have something that I have seen in code, but I have never used it so far.
Yeah, good.
I think it is called label.
Yeah, that's right.
Okay, I give up of the standard library. I should not,
yeah.
Well, I should use as basis to not do what they do. Okay, I gotcha.
Yeah, I'm really going to be in trouble at the next GopherCon or whatever, aren't I? When I meet these people, they'll be like, "Hey, I heard you were talking smack about our library on YouTube." But is this actually on the list of commandments? I can't remember, but I'm pretty sure it says thou shalt not use labels. Precisely because, I mean, clearly the purpose of a label is like this doesn't do anything, it's just identifying a point in the source code, and somewhere else we will be able to say, go to this label. Yeah, that exists. That's a keyword in Go, is go to, and the reason you didn't know that is because you should never use it. And nobody ever does, except maybe the standard library authors. You can also break to a label, so from inside a for loop, you can break to it. Why would you want to do that? Well, one possible reason is maybe you have nested loops. So if you're inside the inner loop and you want to break out of both loops at once, if you just said break, you would just break out of your loop into the outer loop. If you want to bail out of both altogether, you'd have to break to some label. So sometimes it's okay, but I would say, well, try not to write programs with nested loops then. It's not always avoidable, right? But we do the best we can. So where are we going to use that? We're going to use that here, so you can also continue to a label. Why is that necessary? Because we're inside an inner loop here, isn't it? So if we said continue on its own, we would just simply continue this loop, but that's not what's meant. What's meant is continue the outside loop. So, okay, we know what that is. So what's next?
So now we are starting for loop with I value 0, and we will keep going until or while is I is lower than end, which means the last character of the string.
Right. So we already know that end is the length of the format string. So this looks like we're going to loop over every byte of that string. If you know that some runes in Go could be multi-byte, like Unicode characters bigger than ASCII take more than 1 byte, that would be an issue. So you generally don't want to byte index into strings for precisely that reason. You don't know if someone has put some multi-byte characters in there. Here we're clearly assuming that's going to be okay. Not sure if that is justified, but we'll find out. So yeah, what do we think this good argnum is about? The most recent reordering directive was valid. I'm going to ignore that. Maybe we'll find out later, maybe not, but it doesn't seem that important. What I want to know is how is my Hello Code Club going to get printed out, so let's see if we can figure it. Any thoughts about this section? Anyone can sing out if they think
I think we basically go through the string until we hit the % sign.
Yeah, that sounds right to me. So we're saying for as long as I is not at the end of the string and the current byte is not %, just keep incrementing I. So we'll just quickly zoom ahead to the first byte, which is a %. Good. What about this? So no, last I is I right now, or rather, yeah, what last I was where we were before we fast forwarded to the next %, right?
Yeah, I think it basically means we can safely write whatever was there until we found the % sign, because we don't manipulate that.
Yeah. So we're saying start at the beginning, move forward until we find a byte which is not %. If we have moved forward at all, then write everything we skipped over. Right, that makes sense, doesn't it? So in our actual program, the first byte is not %, so we'll fast forward, keep forward, 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 here we go. Okay, now this is the bit that we skipped over. So what do we do with it? We write it to the buffer. So That's something like a bytes buffer, not actually a bytes buffer, but something very like it. So it's just static text, no fancy formatting or anything, we're just printing a string, so fine, so we just write it. And if we're at the end, then we're done. So that's straightforward. We're going to move forward one, because we found, they call these verbs, I've called them placeholders. They're the %s and friends, if that's not clear. Do we have flags? I don't know. You tell me. What are flags? Not sure. I'm gonna guess there's something to do with specific printing information about specific data values, right? Like remember the %1f and things that we saw before. So maybe there's flags about how to print that thing. Fine, it looks like we're getting close to the thing, doesn't it? Like we've written hello, comma, but we haven't written code club yet. So is this the bit where we're going to do that? Let's see. Anybody like to volunteer? Be brave now. It's a safe space. No one will ever know if you screw up, unless they happen to watch it on YouTube, in which case they will.
Sure. So at this point in time, we essentially have the value after our % sign.
Yep.
And that's what we're setting the value of C to.
Yeah, so it's S in our program, isn't it?
Yeah. And then we're going to take that value and we're going to run a switch statement over it and say if it's any of these values, which it's not,
yep.
But then do some things.
Yeah.
I don't know that we necessarily need to talk about what each one of those things are, that we could.
Yeah, but these are clearly sort of things which modify the verb, aren't they? So they're not verbs themselves. Hash doesn't print anything, but if you might know %v prints any Go value, and %hashv or sharpv, if you pronounce it like that, prints a Go struct with field names.
Yeah.
Oh no, sorry, I think that's plus, isn't it?
Plus,
%plus v, and sharp prints out the Go syntax for the value, I think. As you could copy and paste it into your Go code. But as you say, we're not concerned with these, but we can see what that machinery is for. So okay, so it didn't match any of those, so we must be in the default case. So what happens now?
Well, now we're going to basically take a look and see, is my value that I provided between A and Z inclusive, as far as the rune that's concerned.
It's the verb, isn't it? That's what C is.
Yeah, the verb, yeah.
So C is S, as we know, so it is between A and Z. And argnum, which we said is which argument are we processing? It's currently 0. So it's less than the length of the list of arguments. So you could imagine maybe you said thumped printf %s, and then you didn't supply any data, right? So there wouldn't be anything to print. So in that case, then argnum would be greater than len of a, and we would just skip this whole thing. So we just simply wouldn't do anything. So that's kind of interesting.
Yeah, that's good to know.
I think govet might warn you that you haven't supplied enough values, but never mind. So, okay, is it V? No, it isn't. But that's what that does. So it's either V or sharp V, depending, or plus V. So it's not any of those, so it's this, isn't it? So what's that? So we know P is the printer.
Yeah, it's going to print arg. I assume print arg is going to write to the buffer the value of the arg.
That sounds reasonable. That's clearly the thing that does the thing. So let's take a look. So yeah, it takes some data value of empty interface and a verb, which is a rune. I'm guessing that will be the S. And then we get into calling reflect.value. So this is really interesting. That's definitely on the list of commandments. Thou shalt not import the reflect library. That's a bit of a fun one because, of course, there are times when you absolutely need reflect. And this is one of them. But the kind of programs you and I are likely to be writing, we definitely don't need reflect. If we find ourselves doing that, it probably means we've got the wrong design somehow. If only because we should always know what type something is. We should never need to reflect it. It should just be some Go type that we've defined. The only reason you ever need to call reflect is on an empty interface, isn't it? Or some interface value. And we don't use those internally in our programs because we use the type system. So this is great. So I think we're kind of out of time, so I think let's wrap up here and then maybe continue next time, because there's more fun stuff to see and I don't want to just kind of skip over it. So that was very good. Thank you, everybody. Great code clubbing. We will continue our deep dive into the FUMT rabbit hole next time. So thanks for joining.
Thank you.
Thanks, John.
Thank you.